Okay, so in this problem, we have a mixture problem. A 50-gallon tank. So this whole tank, 50-gallon tank, contains 10 gallons of fresh water at T equals 0. A brine solution containing 1 pound of salt, 1 pound of salt per gallon. I'm going to write that 1 pound per gallon. Is entering at a rate of 4 gallons per minute. While the well-stirred mixture leaves the tank at a rate of 2 gallons per minute. So as this is apparently being mixed really well, and it is leaving, the brine solution is leaving the tank at 2 gallons per minute. And we want to find the amount of salt in the tank at the moment of overflow. So I've already written down, we're going to let y of t equal the amount of salt at time t. So we want to create a differential equation using this information. The other thing we know we might as well write is we also have this initial condition where t equals 0, we know that there is 0 pounds of salt, right? Because there was only 10 gallons of water at time 0. They started to pour the brine solution with salt in it, and now we will have a differential equation, dy dt, of this salt being poured in. And it is going to be just looking at the rate of salt going in minus the rate of salt going out. So we need to figure those things out. So the rate in, we know that we have 1 pound of salt per gallon. 1 pound of salt per gallon, and we'll just put 1 gallon too. And it's going in at 4 gallons per minute. So we essentially want to convert that, or what we need it to be is in terms of, because dy dt is going to be in terms of pounds of salt per moment of time. So we need to essentially get rid of the gallons, which we just did. And we have pounds of salt per time. So that's going to be the rate going in. And I'm just going to simplify that really quick. So we know that that's essentially 4. And again, that's pounds per minute. Now we can look at the rate going out. The rate of salt, that the salt is going out. And that we know is 2 gallons per minute. The solution is leaving at 2 gallons per minute. 2 gallons per 1 minute. And again, we want our differential equation is going to be in terms of pounds per time. So we need to essentially figure that out. And to convert that, we need to look at the amount of salt going out, and that's going to be in the form of y of t, because that is our variable, amount of salt at time t, over the volume that's in the tank. So we know that in our tank it is 10 gallons. It starts out at 10 gallons plus we have to look at the rate going in, and the rate going in is 4 gallons per minute minus the rate going out, so the total essentially that's being gained as time goes on is going to be that difference. And again, just to kind of double check, we know we want it in terms of pounds per minutes. This is going to give us that pounds per, or well, after we cancel the units out, the gallons over gallons. And cleaning this up, we will have 2y over 10 plus 2t. And again, just to write this out, this is in pounds per minutes. Just a side note, I didn't write it, but this is pounds over minutes, or gallons. And then, of course, the gallons do cancel out there, and you're left with the pounds per minute. This also can be simplified just a little bit more. If you factor out the 2, you end up with y over 5 plus t. And now we have our differential equation. So we have the right units, everything's in order. We can just write this as dy over dt being equal to 4 minus y over 10 plus, y over 5 plus t. And I'm going to box that so we know our differential equation. And we have our initial condition, so we can essentially solve this now, and that's what we're going to do. I'm going to rewrite, I rewrote this as, instead of y dy dt, I wrote it as y prime. And I also got it in this form, which is the form we want to use if we're going to use an integrating factor, which I am going to do this time. Integrating factor, if you remember, you find it by getting a first order linear differential equation in this form where you have a function of t in front of the y variable, and you integrate that function, which in our case is 1 over 5 plus t dt, and that gives us e to the natural log of 5 plus t. And wonderful things happen with logarithm properties, and we just have 5 plus t as our integrating factor. Again, if you remember integrating factors, you multiply that integrating factor to the whole equation, giving us, when you multiply 5 plus t to this, they cancel out, so you're just left with y there, and that's equal to 4 times 5 plus t, which I probably should have just distributed. And then we rewrite this as the derivative of the function 5 plus t times y being equal to 4, or I'm going to distribute that, being equal to 20 plus 4t, and that's going to be dt, because we are going to integrate to solve, and we need that in terms of dt there. But just to double check, we know that the derivative of this product here, the derivative of y is going to be y prime. with the function in front, plus the derivative of 5 plus t is just 1, and then you have to leave the y function by itself. So we know we did the integrating factor correctly, and we can integrate, and the integral of a derivative is just essentially cancels itself out, so we are left with 5 plus t times y being equal to 20t plus 2t squared plus a constant, right? Then, to get y by itself, we want to divide everything, this whole equation, by 5 plus t. Simplifying that, we have y, and I'm going to write y of t, being equal to 20 over 5 plus t plus 2t squared over 5 plus t plus c over 5 plus t. And we also know our initial value of y of 0 being equal to 0, so we can plug that in to find what c is. So that's 0 plus 0 plus c over 5, which does just end up giving us c being equal to 0. So our function, which, if you remember, is the amount of salt in the tank at time t, which is in terms of minutes. So this equation is our equation that represents the amount of salt in pounds at a certain time in the tank. And of course, we are not done with that. We actually want to know how much salt is in the tank at the moment of overflow. So at the moment of overflow, we also know we have 50 gallons in this tank. So what we are trying to actually find is when whoops, that's not what I'm trying to write. We want to find when the volume of that tank is equal to 50 gallons, right? And the volume of the tank, we actually kind of saw that, because that was, if you go up here, that's actually right around here, because that's the volume of the tank at time t. We know that that is 10 plus 2t. And again, that's in terms of gallons. And I'm going to solve that when it's equal to 50, because that's the moment of overflow. So solving that, when you subtract 10 for both sides, we get 2t equals 40, divided by both sides by 2, and t equals 20. So 20 minutes is when overflow happens. And we want to actually know, again, the question says, find the amount of salt at that moment it overflows. So now that we know 20 minutes is when it overflows, we actually want to know how much salt after 20 minutes is in the tank, right? So doing that, we can now just plug in our t. So 2 times 20 squared plus 20 times 20 all over 5 plus 20. And again, just to remind you, because I'm plugging 20 into this equation right here. Simplifying that, that ends up being 3 times 400, simplifying it a little bit, over 25. And ultimately, simplifying a little more, plugging it into your calculator, you end up with 48 pounds of salt at overflow. And that is it. Very fun problem, right?